Alright, so we have our edge drivetrain and we've done our robot map, so our programmer knows which direction we want forward, so you can do the inverse, which is backwards. And we know we have our motors designated as port 2, 3 and 2, 6, 7 and 6. We know that we're running a gear train right here, so we're taking all of the torque and the speed and we're outputting through our sprockets and then through whatever we decide we want our gear reduction to be, so we can increase speed or inversely increase or decrease torque. So we're going to need to program this thing. So we're going to use RobotC, which I have pulled open right here. And as you go into RobotC, you're going to need to make sure it's going to a physical robot right now. We can also use virtual worlds, but right now we're going to a physical robot. So when I have this selected, I can look down here and I can also see that it is a physical robot it's going to, and it knows that it's going to a Vex Cortex. So as I do this, I can come in here and I can go platform type Vex 2.0 Cortex. You can have natural language on or off. We're not using natural language necessarily, but you can have it on in case you want to use it. There's some tools once you get your Cortex plugged in from the advanced tools like software inspection, so you can actually plug your Cortex in and see kind of the software, if it's up to date, and battery power. And when we start using the hardware kit, when you're programming wirelessly, you'll be able to get feedback from your robot. Make sure you have the menu level on super user, and what we're going to do is we're going to start out with the edge drivetrain, just the base programming. That way we can go through motors and sensors setup. So right now we don't need anything plugged in, but we do need our ports and our motors and our motor controllers and the Y splits that need to Y split 2 and 2 and the front back 6 and 6. We need all of those things set up within our control system. Then we can get to work on our programming. So the first thing we're going to do is look at this window, and we're going to maximize this one. And we're going to look in here, and it's setting up the real world robot using pragmatic configuration, which is here. You'll see pragmatic configuration. That means the real world robot. So we're saying motor in port 2 is the front back right drive. It's a Vex 393 high speed motor, and the motor controller is a MC29. It's an open loop and it is reversed. So if we go back and look at this chart, we know that these two motors, in order to go in the positive direction, this has to be in the negative rotation for the right side, and 6 and 6 has to be in the positive, and this is negative. So make sure we're going to set that up correctly. So we're going to make sure we save this as your team number, like 75160, so you can go to save as and then put your team letter and then just put drivetrain, because eventually we're going to take this and we're going to set it up into a new competition template, which is going to look like this. So we're going to do all the same things, if it has some added features in here, and we're actually going to be putting all of our drivetrain within this area. So that's for another day. Right now we want to work on the edge drivetrain. So we're going to go to the motors and sensor setup, and right now in our motors and sensors, you're going to see that front back right drive is high speed, it's reversed. So on port 3, it is the middle right drive, and it is a Vex 393 high speed motor. It's not reversed, and we're not adding an encoder yet. So we got middle motor, which is port 3, and it's on the right drive high speed motor. We're going to apply that. We're going to look at our code. So already it's assigned another motor to port 3, middle right drive. Same thing, high speed MC29. right? So we're going to go ahead and set the other ones up. We know that port 6 and 7 is our left side. So 6 is FB, left drive. You got to set it for a high-speed motor. And due to the fact we know this is reverse, we know this we leave in a positive direction. So then we set up port 7, middle, left, drive. VEX high speed 393. Now this one has to be in a negative direction to work in our gear train. Remember, when you start adding those odd numbers, is that your two furthest gears are going to spin in the same direction, then your middle ones are going to spin in the opposite, right, to translate that movement. So we're going to apply this. Now we have our real motor set up. So it has our motor, port 2, that's with that Y split, front right drive, port 6, front back left drive, so we know those are Y split. Maybe we should go in here and put a Y at the end. That way we know these are Y split. That gives us a better insight to the drivetrain. Good idea. Alright, so down, if we start looking at the code, this is our real robot, and then we get into task main. So this is one big task that's going to be running a loop. Okay. Now what you're going to see, we are setting an integer and a threshold. So the threshold is like when you touch the joysticks on the controller, it's going to give a value. But when you start moving your finger slightly, it's going to give a value to the motors of 0 to 127. 127 being all the way forward, or negative 127 being all the way back. What we want to do is not look at the values between 0 and 15. That way your motors aren't humming and taking power out of the system. So this is an integer. We're calling it threshold, and that threshold equals 15. So you're going to see where this comes into play right down in here in the code. So this is a while loop. While 1 equals 1, if 1 equals 1, we know it's true. So you could also write true right here. Okay, it would be the same thing, but while 1 equals 1 means while all of this is true, we're still running. So this thing is going to loop over and over. So you have your first squiggly bracket. This is going to open the part of your code you're running while 1 equals 1. Now if we set something up that's like while 1 equals plus minus 3, 4, 5, it would run this stuff, but we would have to set up all the variables. But right now, we're just setting up this basic while loop that's going to run and allow us to drive forward and backwards and test our drivetrains. It's opening up right here. Then I'm calling out an if statement. So it's saying if absolute value of the VEX remote transmitter on channel 3, which is the left side, is greater than the threshold, then I run these motors at the value of what the controller is giving me. So like I said, your joysticks from 0, 0 all the way up to positive 127, it'll read 0 through 127. And in our case, we're looking above 15, so it's 15 through 127. It won't even run these until it gets above that. So as you increase that joystick, it's going to make that motor power equal your VEX joystick. Okay, so right now these are black. That is not good because we said that we have FB. I'm pulling my left. FB left drive Y. Now what you're going to see is as I push compile and it checks my code, it's going to say, oh, I got a motor. Now it's red. That means it's actually reading it. Equals VEX RT channel 3. If it's above threshold, I'm going to move that motor. So you're going to notice that there's going to be X's now. So we have to key in both left side motors. So we know this one was M left drive. See how it turned red? Now it's recognizing both of these as a real robot. So it says absolute value of XRT channel 3 is greater than the threshold. It's going to run these. Else, so it's like a or. If it knows if it's reading the joysticks, it's going to do this. But if else, it's going to tell the motors to do nothing. So if you happen to not put these, you're going to see that your motor is going to still continue to spin after you've already let your fingers off the joysticks, because it's not setting it back to 0. So down here we have to call the same motors out. So FB, left, drive, Y. Notice it turned red. Now we can do middle, left, drive, turned red. Now we have our left side of our joystick. I'm going to go ahead and add a comment. Left side of drivetrain, right? Because this is tank style drive. There we go. Now I've commented it. Now people know what I'm working on. So I'm going to move down to the other side. Channel 2 is your right joystick. So you're going to control the right side of this drivetrain with the right channel 2 joystick. So if I look back up here, FB right, drive Y, middle right, drive. So I'm going to go down here and I'm going to start writing this. FB right, drive, Y. Boom, red means it's pulling it from the pragmatic configuration. M right, drive. Ooh, got it. So now, if absolute value of VEX, the remote transmitter, channel 2 is greater than the threshold, it's going to take the transmitter value and make the motor equal it. So a 127 power is 100% power. Okay, so remember that 0 to 127, but 127 is maximum output for the motor power. So now we are turning them on. Then we got to say or go to 0 if you're not getting any reading, right? So that's FB right, drive Y. Then we come down here and we set that other M right, drive to 0. Now you're going to notice in this code we're opening this while loop. That means we have to close it with a matching brace. Then we have a task main right here, and then we have to close it right here. Make sure you press fix formatting. This will allow you to look straight down in the code and kind of see where your squiggly lines, your squiggly brackets are opening and closing. So if this condition, then do this and set this equal to this or this equal to this, okay? Or set them to 0. Then we move to the right side, if this, okay? Now notice you're working with parentheses and squiggly brackets, opening and closing, and you're calling out conditions, so it's reading everything you want it to read. Okay, now we're going to hit compile, and you're going to notice those X's went away, and right down here, our compiler errors, nothing. So the next thing you're going to do, make sure you save it. Once you compile it, it's actually saving, and sometimes if something messes up, we can find where it actually threw out the version prior to the trash can. Okay, so now this is where we get to plug in our robot into the computer, and we plug it into the Cortex and upload the code into it. Then, like I was saying, once we're using the hardware kit, which is wireless, we'll plug the computer into the joystick. Then we'll use the Wi-Fi keys, those 2.0 keys, to send the signal to the Cortex. So that's wireless programming. So we would download the robot, and you're going to get a message, no communication link available to VEX device. Okay, so it knows that, and it's actually showing you open HID port, and it's saying, oh no, what's going on? Then it's saying destroying window. Okay, so that just means that it can't find what it's looking for. But that is the setup for this drivetrain. Then as we integrate our sensors, what we're going to come back and do is we're going to come back and we're going to add a digital sensor, and it's going to be the quad encoders. So that's going to be entered into the digital sensors. And so we're going to have to say it's a quad encoder. And once you set those up, so if that's in digital 1, it's going to say, hey, I've got a port here to port here. And we're going to say right drive. So we're going to have those quad encoders, call it right drive. And you know it's right drive quad encoder here and here. Now about those digital ones, you can reverse the wires to get both positive directions, and you'll see the output from the window. So we go to apply. The cool thing is, once you start using the debugger, okay, once you're programmed, you're going to see some cool things happen, because you can actually data log on your drivetrain, your robot, and see what it's running. Okay, because there's lots of different things that you can look at, and the more you explore and test things, the better you're going to get at this interface, and then programming with RobotC, which is a C language. So once we get into this, we're going to understand more in C++, and we'll move into Java. Everything's going to be great. So this is how you set it up, and remember, if you're having problems on this drivetrain, that we have to start from the motor, test it with those backup batteries, those whips, then we move to the motor controller, then the cortex. So everything we do, we have to find root cause, and how we do that is we start from one point and we just move our way down and figure out what's going on. So have fun, and I can't wait to see how you do. And when you have problems, make sure you have plenty of questions. Thank you again.